Hey stats guys, today what we're going to do is we're going to look at R squared versus a residual plot and just talk about those differences again and go through the calculator in case you need some more help with that. So the first thing we want to talk about is what is R squared, okay? What we want to do first before we even talk about R squared is we want to look at this association right here, okay? We have the time studying versus grade on a test. We're going to go right now and we're going to go to the calculator and we're going to look at a scatter plot on the calculator, okay? So open up that calculator of yours. Again, I would encourage you to split your screen so you can be watching the video of me and then working on your graphing calculator at the same time, since all of you do have your graphing calculator on your Chromebook, okay? So I split this right here, right? And then I bring this over here. Again, I've shown you in class. If you have any questions, just let me know again. So what I want to do right now is I want to go to stat and I want to hit enter on edit. Now I already have it in the graphing calculator, but I can do this again. So if you have data in your calculator, you want to scroll up to L1, hit clear, and then hit enter. And then go over to L2, hit clear, and then hit enter. I'm going to go over, I'm going to hit 1, 2, 3, 4, 5. This is my explanatory variable. What we are stating is the time we spent studying is going to influence our grade on the test. And we're going to scroll over here and L2 is going to be our Y, our response variable. So we have 70, 81, 92, 95, and 98. Okay. Friendly reminder, if you're on the Chromebook, you may need to set it up again so you can see the R. So we're going to hit second 0 on catalog. If you have a handheld calculator, you only have to do this once. You're going to hit this X to the negative first button. That's D because we need to go to diagnostic on. We're going to hit enter and we're going to hit enter again. So we've put our data into our L1 and our L2. We've gone ahead and we've put the, or we're going to go ahead right now, excuse me. We're going to go ahead and we're going to look at the scatter plot. So we're going to investigate the relationship. I'm going to hit second Y equals, and I'm going to go to plot 1 on. Okay, so I'll give you a second to do that. Second Y equals, plot 1 on. We want to be on the scatter plot. Our X list, that's our explanatory variable, that's L1. Our Y list is L2, and then we're ready to graph. If you do not have L1 and L2, remember to find that you hit second 1 or second 2. Anytime we want to look at a graph in stats, we just hit zoom and then we go to 9 zoom stat, and that's going to show us our graph. So it looks like from this picture, we have a decently linear model. Okay. Oh dear. Control Z. I didn't want to do that. And I did it again. Let's make this a little smaller. Okay, so what I want to do next is I want to find the line that will model what's going on here, the line that I would use for prediction, okay? So let's do that now. Minimize this again. I'm going to hit stat. I'm going to arrow over to calc, and I'm going to go down to number 8. So stat, arrow over to calc, number 8. My X list is L1, my Y list is L2. If you have the old calculator, you can just go ahead and hit calculate. Okay, so we have our line right here. Let me pull this over just so we can see it. I want to make it a little smaller. So we have our line. Let's write it out. We have Y hat, our predicted grade, right, is equal to A, this is our y-intercept, 66.2, plus B, our slope, 7, times X, the time we spent studying on a test. Okay, you do need to know how to interpret the slope and interpret the y-intercept. I've already gone through that with you in a couple videos, so you can go back and look at this, and I want to try to keep this video a little bit shorter today, so I'm not going to do that now. Okay, so when we're looking at this right now, we have this slope, right? We have this, we have this line. And what this line is doing is that it is using, okay, here's my x-axis. It is using time to predict grades, right? And mine's just a sketch. It's not going to match up perfectly how it would maybe look if I would put that on my calculator, but that's okay. And what we want to recognize right now is that there's going to be variation. There's going to be change. And there's going to be change in our grade. So if we would use this line, right? And I would plug a number in on how, so let's say you studied for an hour and a half, right? Let's say here's 1, 2, 3, 4, and 5. You study for an hour and a half. So hour and a half is going to predict someone to get a grade around right here, right? Let's say someone studied 4 hours or 4.5 hours. That means they're going to get a grade around here based on this line, right? What this line is saying is, hey, or what we can say about this line is there's going to be change in my grade. And a percentage of that change is because how long we spend studying, okay? How long we spend studying. Well, that's our R squared, and our R squared is given to us in that output right there, 0.92. I'm going to round to the nearest hundredth, so 0.92, which we can change to a percentage and think about it as a percentage as well. So multiply by 100 or move the decimal over 2 to the right. What R squared is telling us is this is the fraction of variation in Y. So what is our Y here? That is our grade on the test. That's telling us, hey, 92% of the differences in grades is accounted for from how much time we spent studying. How did I know how to put that there? I should have typed it. That took me a while. It's always X in this blank. It's saying, hey guys, that line is saying, hey, we're going to have change. And how much of that change from that line is because of the X value? So 92% of that change in Y on this line is because of how much time we studied. But you guys know that out of a percentage, percentages need to add up to 100%. Well, what's the missing percent here? And hopefully you're thinking, well, the missing percent is 8%. That means 8%, okay? 8% of the change is because of lurking variables. What's a lurking variable? A lurking variable is something else that is affecting our Y, our response, that we're not measuring. So what do I mean by that? We had X, and that was impacting Y, right? Okay, we had X, that was impacting Y. Our X was time. Our Y was grade. What R squared is telling us is 92% of the changes in the grade is because of time. Okay, but there's an extra 8% out there that's affecting the grade, and that's lurking variables. How many of you know people who can not study at all and get a good grade? Okay, so one thing could be IQ or how well someone knows a certain subject to begin with. How many of you have ever gotten a bad grade because you didn't get much sleep the night before, but you actually knew your stuff? How many of you didn't eat a good breakfast, right? How many of you maybe are in a relationship, having relationship issues, whether it's with your mom, dad, brother, sister, boyfriend, girlfriend, and you think that maybe affected your grade? What we're saying is that 8% of the change in the grade is not because of how much time you spent studying, but maybe because there's some other factors influencing your grade. That's called a lurking variable. Okay, that's called a lurking variable. Now, the last thing that you need to know, kind of when we're talking about one thing influencing the other, is we can say that there is a positive relationship between X and Y, right? Between time and grade. But just because there's a high correlation right here, you see this right here, 0.95719, our high correlation R value does not necessarily mean causation. That just because we studied a lot, that is actually going to cause us to get a good grade. The only way we can prove this is through a well-designed experiment. And we're going to learn about what is a well-designed experiment in the next chapter. So that's one thing to remember about the correlation coefficient, your R. Now, some of you might be thinking, wait, what's the difference between R and R squared now? R is talking about the variation within the points, like kind of how well do they hover over this line? Is there a lot of, are they hovering a lot? Then your correlation coefficient is going to be close to 0. Or is it covering nice and tightly? Like here, it's really like hovering over that line nicely. That's what that R is talking about. The closer it is to 1, the closer these points will be looking like a straight line. The further it is from 1, the less it's going to hover, right? You're going to have points like out here and so on and so forth. But again, if it's 1, it's going to be a straight line. Okay, so just as a reminder as to what that correlation coefficient, that's talking about the points. The R squared is talking about how well is this line, or the R squared is talking about the variation in Y when we're using this line for prediction that can be accounted for by X. Now, if all of this is over your head, the bare minimum, you need to understand how to fill these blanks in, and then come talk to me and maybe I can say it in a different way for you, okay? Lastly, I want to just remind you how to look at that residual plot. That residual plot is telling us something different. That residual plot is telling us, is the line appropriate for prediction? Okay, so we know when we use this line how much variation, in Y is because of X. But is the line even appropriate to use, right? Or is there a better model out there? Just like when I talk about, I want to measure my husband's height, I want to measure my husband's height. I want to use a ruler. Can I do it? Sure. But is there something better out there, a more appropriate measurement tool? So what we want to do then, after we run regression to look at our residual plot, just so you can learn how to use that calculator, we hit second Y equals. We hit enter on plot 1, and we go to the Y list, and we need to change this to resid. And to get there, we need to hit second stat. So I'll give you a second. What did we do? I'll repeat, second Y equals, hit enter on plot 1. And we can only do this after we run regression, after we get that line, that R and that R squared. We scroll down to L2. We hit second stat. And resid is right there, number 8. And now we can hit zoom 9. And what do you know? Look at that. We have a residual plot that looks like a V or a U, which means really our line is not appropriate for prediction. Since there is a pattern, our line is not appropriate to use for prediction. Okay, R squared, we should know what R squared is, how to interpret it, what does it mean, what's the difference between R, and how to get to that residual plot, as well as feeling better about using that calculator. Thanks, guys, and have a great day.